Hello, everybody. That last video I did was so long. I had no idea that I ran on and on so long, but it is what it is. So we're going to pick up with these two X functions, right? So I think they're all going to be pretty similar in the fact that they take a structure or a type and change it to another type. We'll see if I'm right about that. So this first one, we're not going to go too much into this. Surely we've used toLower. It is the curried. Um, oh, it's not even curried because it just takes one argument. It just flips it so that you call it like a function, not a method. And toUpper is going to be the same way. So, at least you can partially apply it. No, you can't partially apply it. What am I thinking? There's nothing to partially apply. It takes one argument. Yeah. So toLower, you pass it in a string and it gives you lowercase string. Uh, so let's move on to pairs, which is a little bit more interesting. It takes an object, with the key as a string, and the value can be anything, and it's going to return a pair or a list of pairs. Um, it's right there in the name, isn't it? So it's going to take the object to extract from, and it returns an array of key value arrays from the object's own properties. So a list of pairs converts an object into an array of key value arrays. Only the object's own properties are used. So that's good to know. It's not going to go and grab default properties that the object might inherit from. Note that the order of the output array is not guaranteed to be consistent across different JavaScript platforms. And that's because objects don't have an order. They're named instead, or the values inside objects have names, which are the keys. Therefore, it doesn't really make a whole lot of sense to order them. And I have seen from personal experience, different browsers will iterate through an object in different orders if you call the function over and over again. Um, and did think I saw something a couple years ago where the browsers might have changed that, but that's not what you want from objects. If you want an ordered, if you want to hold multiple values inside one thing, like one constant or variable or whatever, you want to use an array for that. That's what it's there for. And arrays can hold objects, you know. Um, so it says see also from pairs, keys, and values. And I think we've looked at all these. I think we looked at values when we looked at keys. Keys gives you all the keys from an object. Values gives you all the values from an object. And from pairs is the opposite of this. So let's say we have an object. Let's use this, the d.obj. Looks like this. It's got an ID of 1, name of test, and active is true. And let's convert that to pairs. So r dot to pairs. And we pass in our one argument, which is an object. And we get a pair instead of a key value pair in an object. We get an array, like this would be more technically like a tuple, um, where the first item is going to be the string and the second one's going to be the value. And then if you wanted to do this for a list of objects, you could map and convert everything. Um, so this is just going to handle one object though. And then from pairs, just peek at it real quick. See, it takes the key value array like we've created and returns a uh, key value. So if I take this and I call it x's, then I could say from pairs and pass in my x's. Maybe that should be xss, but who cares? And then I get right back to where I started. So these are the opposites of each other from pairs and two pairs. Yeah, pretty straightforward. And then we've got two pairs in, and I already know because of the naming structure when they come up with names for these functions in, they took the time to decide that in is going to mean something, and it means that where this one gets the object's own properties, this one is going to get the inherited properties as well. Notice the type signature is the exact same. So let's read this. So it converts an object into an array of key value arrays. The object's own properties and prototype properties are used. And then note that the order of the output array is not guaranteed to be consistent across different JS platforms. So the only thing different is this sentence about the object's own properties and prototype properties are used. So I don't want to have to go through and make a class. So let's just grab this example here. So we've created this function f, and this is like old school before we had classes, and some people still do it this way. So it's just got its property, right? The When you create an instance of f, the value is going to be x. Normally you'd pass that in as a like parameter, but this is fine too. But then we go to the prototype, which is where the methods live, and we create one called y and give it y. So this isn't, I said method, but I guess you can use this for to add on other properties, which you wouldn't really do very often, if ever. And then so we create a new instance of this f class um, using the new keyword. So now we've got this f object. And what are they doing? Two pairs? Oh, yeah, that's what we're doing here. So when we run it, we're going to need to give it an object. We use that same d.og obj. And when we run it, goodness, third time's the charm. When we run it, we get our pairs, but it is showing us the one that's on the prototype, so it's going up the prototype chain. But if we just did two pairs, we're just going to get the first back like that. So I don't see a lot of reasons why you want to do this, um, but it's there in case you do. And I guess it's reasonable, like, there's always going to be edge cases, so don't limit people from not being able to do these things. But it does just make it more to learn and to sift through. So now we have our toString function, which takes anything and returns a string. And this is the kind of method that you will find on just about everything. There's a toString method. And so I'm guessing this is going to be similar. Let's expand the parameters and see. It just returns a string, or it takes a value and returns a string, any value. I do want to look at the implementation. I just want to glance at it real quick. Okay, so they're using their own internal toString function on the value, passing in an array. That's interesting. So now I want to go look at that. They're importing a lot of stuff here. Okay, so basically they're implementing lots of different toString functions based on what type of value it is. So like you got arguments, array, boolean, date, map. And the reason I was looking at this is I wanted to see if they were just using the toString method, and if this is just a way to call it where the data is provided as an argument instead of the subject like this, like the object-oriented way. Um, but there's a lot that's gone into this, obviously. So given how simple it is and how simple the type signature is, I'm a bit surprised to see so much documentation. Well, let's read it. It returns the string representation of the given value. Now, see, I feel like they would have just stopped there. Evaluating the output should result in a value equivalent to the input value. Okay. Many of the built-in to string methods do not satisfy this requirement. Okay. So now we're in like the equals territory of Ramda, where not only are they implementing this as a function instead of a method, they're also changing some of the things that we don't like about native JavaScript, which there are many. Um, Not hating on JavaScript though, but that's just the reality. It's a big language. There's a lot going on. If the given value is object to object with a toString method other than the built-in object toString method, this method is invoked with no arguments to produce the return value. This means user-defined constructor functions can provide a suitable toString method, for example. Oh, sorry. For example, all right, so let's look at this piece by piece. So we make a function called point, and it's like an old school class where we're going to use the new constructor or the new keyword to create an instance of this point object or point class. So this is like a constructor taking the x and the y and assigning it to this dot x and this dot y. And then we're going to add a toString method onto the prototype. So again, old school syntax, function statement, but anonymous. And we're just going to return this string, this like formatted sentence using the value of the point. Or we say the new point, like 3 and 4. Okay, and then here we're going to call toString. Okay, and we're instantiating a new point with x is 1, 2 is, or y is 2. So we've got our new thing. We're just not assigning it to a variable. We're going to invoke toString on it, and we get this new point 1 and 2, just like it returns. Okay, so that is all in reference to this paragraph. If the given value is object to object, which is like, I don't know why it's so hard to copy out of there. So we've got that, and then if we did like const point equals new point 3 and 2, and then we call, let's just log that and see what we get. Point we're going to get the, okay, so it says point, and then we get x3, y is 2. So that's how Node does it. Um, but a lot of times you'll get that object in the console. Like if I did all of this in the browser console, I realize there's not a lot of room here, but we'll get through it. All right, so we do all that there, and then I want to see what a point is. I get the same thing. Maybe that's because it's in the console, though. I'm trying to simulate where I get, oh, I lost my place. Trying to simulate where I get this object. Oh, it's when I do this. When I call toString like a method on the object, and I get object, right? So if a given value is an object with a toString method other than the one that I just used, this method is invoked with no arguments to produce the return value. This method is invoked with no arguments. This means user-defined constructor functions can provide a suitable toString method, for example. Okay, so if I did, okay, well, that's what they're doing, but I skipped that part, didn't I? We're making our own toString method with this format. And then if I call it, and I'm not making a mistake or I'm making this on purpose, so that's what we get before. But if we call it like this, and it's r dot in this case, r dot string, like gives me new point. Yeah, new point. That's what we're supposed to get. New point 3 and 2. But if I don't call it like this, then I get it like that. And that's probably what we're after if you're trying to convert this into a string. You want to serialize it or stringify it. But I can override that by creating my own method. And Ramda will reach into that and use that as the function. And then if I go back to point to string, like the built-in way, then I'm going to get the object, and that's not helpful. And then what did I do to get the new point? Save it. Okay, yeah, so that gives me that. Ah, yeah, but if I bring this back and I just call it like this, then I get the new point 3, 2. Yeah, that's cool. I mean, in debugging, especially, that might be handy. It's definitely a little bit more sane than the built-in two-string, like more useful, and you'll get the hang of like what you need to do to make what you want happen. Like there's three scenarios. There's the one where we make our custom output, the one where we get the output like this, and then the one where we get the output like object object, which is never what you want really, unless you just want to know if the value is not like a simple value, like a number, string, boolean, undefined or void, or undefined or null. Yeah, cool. So that is toString. And then we've got toUpper, which we covered, takes a string, returns a string, lowercase or uppercase, and gives you back uppercase. So transduce, pass. Sorry, I just don't know enough about it. Um, and I don't know enough about it. And I don't have enough of a background to understand what this does. It's related to reduce, um, but there's more to it, and I want to understand the underlying concepts a little bit first before I try to get into it. Because I've looked at this and I understand the examples, but I just don't understand why it's a transduce, you know. So anyway, sorry, gonna pass. But for transpose, we can look at this one. And, in fact, I think this would be a good place to stop because that grouped well with these functions that started with two. I'll pick up on the next one and then we'll get into transpose. Thanks for spending your time with me. Tell a friend, and I'll see you in the next video.